What if I tell you that you can approximate the exact solution of a function without actually undergoing their differential equation? That might sound impossible, right? In this video, I'm going to show you how the Euler's method have been utilized by engineers and scientists to approximate the true value of a function in simple steps. Now, let's say we are given that dy over dx is equal to x plus y, and we are given that y of 0 is equal to 1. Now, what is the value of the function? What is the value of the function at x equals 0.4? So obviously, we're going to be employing the Euler's method or the Euler's method to solving this problem. Now, when utilizing the Euler's method, there are two formulas I want you to keep in mind. The first formula is the successive values of x, and the second formula is the successive values for y. For x, the equation is simply given as xn plus 1 equals xn plus h. And for y, the equation is given as yn plus 1 equals yn plus h multiplies by f of xn comma yn. Now, f of xn or f of x n comma y, f of x comma y itself is simply the given derivative dy dx. Is simply dy all over dx. So since the values are made up of x and y, we simply call that a function of x and y. So in this case, it is x plus y. Now, there is an important term from this formula that can be seen, and that important term is this term called h. This term is a very important term in this formula. It can also be seen in the y equation. This h is called an interval or a step size. The h is called a step size. So most times it is given to you in a question, and most times it is expected that you choose your step size. Now, in choosing your step size or in selecting your step size, always consider the step size to be as small as possible, because using Euler's method, the smaller the step size, the more accurate the approximation. So in this given question, we've not been given a step size, but then when selecting a step size, also keep it in mind, work with what? The value to which you're approximating. Look at the value to which you're approximating and make your decision for the step size. Since the value to which I'm approximating is in decimal, 0.4, it means my step size is also going to be in decimal. But the key word here is the smaller the step size, the better or the more accurate the approximation you're going to obtain. So even if the value you're to approximate with respect to is a whole number, if you have the patience to choose your step size to be a decimal, it is also better, because the smaller the step size, the better the accurate result or accurate approximation you are going to obtain. Now, we've not been given a step size in this question, so I'm going to simply choose a step size of 0.1. h equals 0.1. Now, like I said, since the value to which I'm approximating with respect to is a decimal, then I simply choose a small possible value also in decimal for the step size h, 0.1. So this means now I need to find the value of x that corresponds. I need to consistently add x until I obtain x to be equal to 0.4. Now, another thing to keep in mind is we are given here that dy dx is x plus y, and we are told, given a condition, an initial condition, y of 0 is equal to 1. This condition, y of 0, can be represented as we have y of 0 equals 1. This is simply y of x naught equal to y naught. So if you make this comparison, you now find out that when y is equal to y naught, and which is equal to 1 from this condition, x itself is equal to x naught, and the value is equal to 0. So this means this term in this bracket is our x naught. y of x naught is equal to y naught. So this y is actually y naught. This means our y naught is equal to 1, and then our s naught is equal to 0. So y of 0, 0 there becomes our s naught. So this means that we are starting our approximation from when n is equal to 0. We are starting our approximation from when n is equal to 0, this subscript here. So if we do that, we are going to have, now let's make a table. This is our n values. When n is equal to 0, we are now going to obtain our xn. Our xn there becomes x naught. Okay, x naught. And this s naught is going to be equal to, from the question, s naught is simply what? 0 from the initial condition. So x naught here is 0. Okay, and then again, our y becomes our y is going to be what? Yn becomes what? Y naught, because n is equal to 0, and y naught is also from the given initial condition, y equal to 1. So y naught is simply equal to 1. So what we need to do now is we need to now split this value of n to match up to x equals 0.4. So we have considered when n is equal to 0. Next, we consider when n is equal to 1. What is now going to be the value of x naught? What is now going to be the value of xn and yn? So when n is equal to 1, it means my xn becomes what? X1. Now, what is x1? X1 simply means I will fall back to the equation for x and plug in the previous values. So that's why it is called the successive value of x, which means the next value of x. And those next values are obtained by imputing the previous values of x into this equation and adding it with what? The step size. Okay, so to get my x1, it means I'm going to be putting n to be equal to 0. So when n is 0, equal to 0, from this equation, this becomes x0 plus 1 equals x0 from here. In place of n is 0 plus h. So that simply means that our x0 plus 1 now becomes x1, and that's equal to x0 plus h. So this means to get the next value, I will simply impute the previous value into the equation for x and add the step size. Meanwhile, the step size remains constant and doesn't change. So if I do this, I'm going to have my x1 to be equal to, okay, I'm going to have my x1 to be equal to x0 gave us 0. So that's simply 0 plus h there. The step size we selected 0.1. So this is actually what? 0.1. So it means my x1 is 0.1. Then what then is my y1? Y1 is also obtained by imputing the value of n as 0. So from this equation, I have yn plus 1. That becomes y0 plus 1 equal to yn, and n is 0. So I have y0 plus h multiplied by f of xn comma yn. So I have x0 comma y0. So which simply means in place of n now, n is 0. So xn becomes x0, yn becomes y0. So this means that this equation now becomes y0 plus 1 is 1 plus y0, equal to y0 plus h multiplied by the function at x0, y0. Now, this means evaluate the given function at x0, y0. What is the given function? Our differentiation. We said that earlier. Our derivative becomes our function f of xy is simply dy all over the x. So this is now our function. So this means that I will first of all, in order to find a value for y, I have to evaluate the value of the function at the previous values of x and y. So if we do that, we are going to have that f of x0, y0 is going to be equal to, so in this equation, wherever you see x, you put in the value of x0. So this is x0 plus y0. This becomes x0 plus y0, and this is equal to x0 there from the equation was given to us as 0, y0 was given to us simply as 1. Y0 is simply 1. So this implies that the value of the function at x0, y0 is equal to 1. So if you have this, then we can now find the first value for y. y1 is now going to be equal to y0 is 1 plus, remember, h. And our step size h is 0.1. So plus 0.1 multiplied by the value of the function at those points, and that value is 1. So this simply implies y1 is equal to 1 plus 0.1 times 1 gives us 0.1, and therefore y1 equals 1.1. So it means the value of our y1 is equal to 1.1. It's as simple as this. So what happens next is, if I want to find x2, this is when n is equal to 2. So if n is equal to 2, it means now that my xn becomes what? X2. And how do I find x2? By simply going back to this equation and plug back the previous values. So n becomes what? 1. So from n plus 1, if my n is 1, then I have what? 1 plus 1. That gives me x2. So when n is 1, when n equals 1, it means my x becomes x, my xn plus 1 becomes x1 plus 1, which is x2, and that's equal to, once again, the previous value. Xn becomes x1 plus h. So x2 is going to be equal to x1. We obtain the value of x1 as 0.1. So simply plug there. I have 0.1 plus the step size itself is 0.1. So this implies that x2 is going to be automatically 0.2. So my x2 is 0.2. That is settled. Next, I find what? My y becomes what? y2. Okay, y becomes y2 when n is equal to 2. So what then is y2? We repeat the same process that we've done. So now we are plugging in the previous values of y into the equation to obtain what? y2. So let's do this and see. So our equation now becomes, from here, instead of y1, this becomes y2 is equal to, this now becomes y1, the previous value, y1 plus h f of x1 y1. So this means I have to evaluate the function at when x is 1, and sorry, at x1 and at y1, then add up, multiply by the step size, and add up with the previous value of y. It's as simple as this. Let's make out some space. So once again, you recall that f of x y is equal to x plus y, which is our derivative there. So this is going to be equal to, now our x is now x1 y1. We need to plug in the value of x here as x1 and the value of y as y1. So this is going to be, our x1 gave us 0.1, our y1 gave us 1.1. So this is going to be equal to 0.1 plus 1.1, and this is approximately, or this is going to be 1.2. So the value of the function at those points becomes 1.2. What then is the value of y? From this equation, you can find y2 to be equal to, it says y1, and y1 is 1.1 plus h 0.1 multiplied by the value of the function, and this is the value we obtain, 1.2. So this simply implies that y2 is going to be equal to, so I will simply multiply everything and add up all at once. That gives me 1.22. So my y2 is actually 1.22. So here I have 1.22. Now remember, the target is to stop as when x is what? 0.4. So since we are still at 0.2, it means we still continue. Find when n is equal to 3. When n is equal to 3, it means my x becomes x3 and my y becomes y3. So we need to find x3 and we need to find y3. To find x3, what do we do? Still this equation, x2 now from here, this now becomes x3. So I'll simply plug back the previous values. In place of x1, this is now going to be x2 plus h. The step size remains constant and it doesn't change, right? So x3 equals, what is x2? We obtain x2 here as 0.2. So you have 0.2 plus the step size is 0.1. So this simply gives us 0.3. So my x3 is 0.3. So we are done with x. We move next to y. Now to get to y, we have to now evaluate the function at points at the previous values of x and y. So since here we consider x1, y1, So we'll simply find a function at point 2. So this is going to be x2, y2. What is now the value of the function at point 2 as the 2, right? So the equation is x plus y. So this x now becomes x2 plus y2. So this becomes x2 plus y2. Now what is our x2? X2 is 0.3 and our y2 is 1.22. So we simply change here to 0.3, 0.3 and 1.22. So we find 0.3 plus 1.22. That gives us 1.52. So we have this value to be 1.52. So the value of the function at that point is 1.52. Now we need to find the value of y3. So y3, this becomes now y3. Okay. Y3 is going to be equal to simply y2 plus h f of x 2 y2. Okay, it's as simple as this. So for every new state level you go to or new point you go to, always record the previous values to obtain your successive values for y. Okay, so from here now, this simply implies that my y3 is going to be y2. We obtained y2 as 1.22. So you have 1.22 plus the step size remains 0.1 multiplied by the function at that point. We got it to be 1.52. So y2 is going to now be equal to, so I will simply evaluate everything together. 1.52 multiply 0.1 plus 1.22. So this gives me 1.372. Y2 is 1.372. So when n is equal to 3, y3 please, not y2, y3. y3 is 1.372. So I have 1.372. Okay. The next, since we are still at 0.3, now we consider when n is equal to 4. When n is 4, our x becomes x4. What then is the value of x4? Still the same equation. We simply fall back here now. In place of x3, okay, let's take this off. So instead of x3, this now becomes x4. And this becomes x3 plus h. So the values remain the same. For the next value, I will record the previous value of x and add it up to the step size, right? So x4 is now going to be, x3 gave us 0.3. So I have 0.3 plus my step size from the equation is 0.1. So this simply implies that my x4 equals 0.4. So this is where we stop. X4 is 0.4. So we simply stop here. Since we've gotten the value of our x4 at 0.4, we pause. Now we find the value of y4. Y4 is now going to be, before looking for y4, we need to evaluate the function at the previous value. So we need to evaluate the function now at point 3. So this is now going to be f of x3, y3. So this means x3 plus y3. You have this. So we simply sum up the values of evaluating function at these given points. Okay. So our x3 is 0. Sorry, our x3 is 0.3. We simply have 0.3 plus our y3. Y3 give us 1.372 plus 1.372. So plus 1.372. So this gives us 1.672. So the value of the function at that point is 1.672. With this, we can now find the value of y4, which is the final value of y. So we evaluate now at state 4. This is now y4, and in place of y2 here, it becomes y3. Okay, plus f of x3, y3. Simple. So now you have y4 to be equal to, what's our y3? We obtain y3 here as 1.372. So 1.372 plus our h is 0.1. multiplies the value of the function at the previous values, gave us here 1.672, 1.672. So this simply implies that the value of y is going to be equal to, so let's simply evaluate everything together. 1.672 multiplies 0.1 plus 1.372. This gives us 1.5392. 1.5392. And this becomes the approximate value. Y4 equals 1.5392. This becomes the approximate value of that function when x is equal to 0.4. So it's as simple as this for the Euler's method, right? All you need to do is to get the successive values of x and y, always record the previous values of x and the previous values of y, keeping in mind that the smaller the step size, the better and more accurate your prediction is going to result into, right? So always keeping that in mind, or always keep that in mind. In the next video, I'm going to be solving tedious examples. This is just an introduction video. In the next video, I'm going to be solving tedious examples to explain this concept. Just in case you also have any question at all that is challenging on Euler's method, do well to drop it in the comment section, or you can message me directly on my WhatsApp displaying up there, and I will do well to respond to your messages. I will see you in the next video. Cheers.